Hello guys, and welcome to another video on engineering mathematics exam review. So for our topic today, we are looking at Laplace transform method of solving ordinary differential equations, and our question will be a past question from engineering mathematics, question number 7A 2022-2023, using Footholes examination paper. All right, so for those of you that don't know what FUTO means, it means Federal University of Technology Owerri in Nigeria, one of the best engineering schools out there. So if you are not from FUTO, you don't have to worry. This video is also for you. You can learn a lot of things. Okay, if this is the first time of you looking at my channel, I enjoin you to please subscribe, and you can check the playlist. You'll see a lot of stuff that you actually need as an engineering student. A lot of videos, ordinary differential equations, engineering mathematics 308, and a lot of things on control systems. So subscribe, hit the notification bell to stay updated, because I'm going to be dishing out a lot of things that will be helpful for you as an undergraduate engineering student. Now let's dive into the solution of this problem. First of all, the problem is you need to solve the following differential equation using Laplace transform. Now I'm not going to dwell much on the intricacies of Laplace transform, because I've already covered Laplace transform in details in one of the videos in my playlist. So if you want to review Laplace transform, you could check that video out. But I'm just going to dive straight into the solution, and I'm sure that's what you've been anticipating. So why don't we dive in? All right, let's go. Solution. So first of all, to solve this problem quickly, you take the Laplace transform of both sides. So taking the Laplace transform of both sides, assuming you labeled this as equation 1, you can say of both sides of 1. Okay, so Laplace transform of d squared y by dx squared plus 5 dy dx plus 6y equal to the Laplace transform of 0. Okay, so when we take the Laplace transform of d squared y by dx squared, we are going to get s squared y, okay, of s, and minus s y of 0 minus y prime of 0. So this is just for only this. Okay, so when you take the Laplace transform of this guy, you're going to get this. Then you put plus 5, that's a constant, in brackets. The Laplace transform of dy dx is going to give me s y of s, then minus y of 0. And finally, the Laplace transform of 6y is going to give you 6 capital letter y of s, and the Laplace transform of 0 is still 0. Okay, so I'm going to extract all terms having y of s attached to them, and I'm going to collect other terms together in this fashion. So what I have here is s squared plus 5s plus 6. This is the characteristic equation, and all of them are attached to this y of s. Then another term, okay, I hope you understood how I did that. S squared and 5 times s is 5s, then 6. So you just extract y of s from there. Then next one is, remember your initial conditions, y of 0 and y prime of 0. That is what it means. So our y of 0 is 2 and our y prime of 0 is 3. That is the initial displacement and the initial velocity. Anytime you have a second order differential equation, the initial conditions must be displacement and velocity. Okay, so when you have your initial displacement to be 2 and your initial velocity to be 3, you can just substitute it into this equation, and you're going to get minus s bracket 2. Then you now have minus, this one is going to give me a 3. Then you now have, opening this bracket, 5 times whatever is here, give me minus 5 times 2, because y of 0 is 2. So I think we have taken care of everything that needs to be taken care of. This 3 terms on this 3 terms, so 6 terms altogether, and they are all equal to 0. So you can check it at this point to see that we are both on the same page. Okay, so let's continue if you're here with me. So I have an s squared plus a 5s plus a 6 y of s. Then you now have minus 2s. If you evaluate this, minus 3 minus 10 gives you a minus 13 equal to 0. So you can have that your y of s is going to be 2s plus 13 divided by what? S squared plus 5s plus 6. So if you want to find the original y of x, that's the equation of the displacement, your y of x can be gotten by taking the inverse Laplace transform of y of s, which is the inverse Laplace transform of 2s plus 13 divided by s squared plus 5s plus 6. Okay, so we are going to focus on getting the inverse Laplace transform of this particular partial fraction over here. So this fraction, sorry, s squared. So let's consider we have 2s plus 13 divided by s squared plus 5s plus 6. It's still equivalent to 2s plus 13 divided by, looking at this one, it's easy to factorize into s plus 2 and s plus 3. Is that okay? And this will now factorize to a all over s plus 2 plus b all over s plus 3, like this. So I hope we are all on track. Okay, so we have 2s plus 13 all over s plus 2 s plus 3 is equivalent to a all over s plus 2 and b all over s plus 3. Wow, amazing. These are all linear factors. That makes it easy for me to apply the cover-up method. Okay, so if you don't know the cover-up method, look at some videos in my channel and you see it fully explained. But I'm just going to dive into the application of the cover-up method to simplify the value of a and b in just splits of second. So the value of a will just be the limiting value as s tends to what? So what value are you going to put into this factor that is under a to make it get to 0? What number of s are you going to put to make it get to 0? Definitely minus 2, because if we put minus 2 and this plus this will be 0. So a is the limiting value as s approaches minus 2. Then you apply the limit on this particular big fraction over here. The only thing is that you're going to cover up the factor that is under a, which is the s plus 2. So that's why the name cover up method comes to play. So you have 2s plus 13. So if we cover up s plus 2, we'll just be left with s plus 3. Is that okay? So I hope you understand the steps. You take the limit as s approaches what? Any value that will make the factor under a vanish, as far as it's a linear factor. Okay, then you will now cover up that linear factor and apply the limit to whatever is left, which is going to give me 2 brackets minus 2 plus 13 divided by minus 2 plus 3. This gives me a negative 4 plus 13 is a 9 divided by minus 2 plus 3 is 1. So the value of a is 9. Okay, that's all about getting a. Now, if you want to get b, you get b by applying the limiting value. Very good, as s tends to what? Very good, minus 3, because minus 3 is the number that you impute into this factor over here to make it vanish to 0. So you apply this limit on the big fraction at the left hand side, only that you cover up what? B. Very good, the factor under b. So covering up that factor, you'll be left with s plus 2. Okay, so applying this negative 3, you have 2 into negative 3 plus 13 divided by negative 3 plus 2. 2 into negative 3 is negative 6 plus 13 is a 7 plus 7 divided by minus 1, which gives me a negative 7. Is that okay? So having done this, we've gotten the values of a and b. So we can now represent our s. 2s plus 13 divided by s plus 2 and s plus 3 as what? we have 9 all over s plus 2. We now have minus 7 all over s plus 3. Okay, so you can check whether this minus this will give you this by yourself, just to be sure that it's correct. So we can now remember that our y of x is actually the inverse Laplace transform. That's the implication of this whole stuff. 9 all over, let me write it well so that that 9 will not look like a. 9 all over, oh, sorry about that. You have 9 all over s plus 2, then minus the Laplace transform of 7 all over s plus 3. Okay, so the y of x will be the inverse Laplace transform of everything individually that is there. So you have your y of x to be the inverse Laplace transform of this one is going to be 9 inverse Laplace transform of 1 over s plus 2 minus 7 inverse Laplace transform of 1 over s plus 3. And if you're familiar with your Laplace transform table, your y of x is going to be 9 exponential minus 2x, and you now have minus 7 exponential minus what? 3x. So the idea is that the Laplace inverse of 1 all over s plus a is exponential minus ax. Okay, if we are dealing in the x domain. So this is the solution of this particular question, and yeah, that's all. So if you enjoyed this video, please don't forget to like, and if you have any questions or comments, leave it in the comment section. So I look forward to exploring more questions with you, but in the meantime, please subscribe to my channel and hit the notification bell to stay updated. Thank you for being a blessing to my channel. We are 400 subscribers stronger, and I hope that this number will increase. So take care and all the best in your exams. Goodbye.